Hey, here we are again, and in this lecture we will continue building our real-world motion detection program. Now, before I go and write the code, I would first like to explain to you the architecture of the program that we will be building. So how this program is able to detect motion in the video. And I assume you already know how to build this script, so we built this in the previous lectures. And what the script does is that, in case you've missed it, hey, so what this does is it triggers the video, as you saw, from the computer webcam. So we're processing frames here in this while loop, and so on. So you know this. I will not go through them right now. So what we need to do next is we need to process those frames that are being iterated in this while loop. And I've got some pictures here to illustrate my ideas, my concepts. Let me go to the directory where they are located. So what this motion detection program will do is it will trigger the webcam just like our current script does. And one condition for the program to work well is that once you trigger the webcam, the first frame of the video should be the static background. So if you're planning to use this program, let's say you'll set up a webcam on a laptop or a Raspberry Pi server. Let's say you want to detect the movement of a certain animal in an area. So first you'd want to capture to trigger the camera while the background is static, and then you want to use this background as a base image so that you can compare the other images, and then Python can detect if there is a change between the first frame and the next frames. So that's one thing you need to do. And so this is an example of a background, and then the animal will appear on your camera. Okay, and then what you'll have to write in your script in the program is that first we would want to gray out this image, so the background image, and the current frame of the camera. So you'll store the first frame of the video capture in a variable, and then you'll convert that frame to a grayscale image, and then the while loop will go through the current frames, and you'll do the same for the current frame, so you'll convert them to grayscale. And then what you'll do to these two grayscale images of the current iteration of the loop, you'll apply the difference between them. So this is the difference, an example of a difference frame, of a delta frame, if you can say like that. In this particular image, you'll notice that behind me there is the lamp of the room. And normally you wouldn't be able to see the lamp, but Python is actually making the difference between the frame where I was appearing and the background frame where the lamp is visible. So it comes up with this gray image where each pixel has a certain value. So it has some intensity values. Alright. So that means, for instance, the high intensity values, like this one where I am, it means there is potential motion in this area here, while the black areas imply there is no motion. But you also see some light black pixels here, because when I appear on the camera, there is shadow behind me and so on. But we will apply something else later on, which is called the threshold. So we'll basically say that if you see a difference in the delta frame, in the frame that I just showed you, if you see a difference of more than 100 intensity, convert those pixels to white pixels, okay? And for pixels that are below the threshold, convert them to black, okay? And so you come up with the outline of the object that is moving in the camera, in the frame. So we're doing all these processes inside the while loop, and then once we have calculated the threshold frame inside the loop, what we'll do to the current frame is we'll find the contours of the white objects in the frame, okay? So for this particular image we would have the contours around this object here, and the contours around this and around this as well. And then we will write a for loop that will iterate through all the contours of the current frame. Okay, it will go to this contour, to this, and to this one. And then inside that loop, what we'll do is we'll check if the area of the contours, so this, for example, has an area of, let's say, 500 pixels. So if the area of the contour is more than 500 pixels, for example, then consider this as a moving object. If the area is, let's say, less than 500, like this one here is probably 20 pixels, let's say, this will not be considered a moving object. Okay, I hope that makes sense. And then what we'll do next is we will draw a rectangle around the contours that were greater than the minimum area. And then we'll show those rectangles in the original image, so in the color version of the current frame. That means we will see a rectangle in the video. While the video is playing, we'll see a rectangle around the object. And later on we will detect the times that the object, the moving object, entered the background, the video frame, and the time that the object exited the background. But for now, let's simply focus on detecting the object, the moving object in the video. Okay, and let's go back to the script. Close this, and this, and this. Okay, and let's remove some unnecessary lines here. So we had the A variable here, which we created because we wanted to see how many frames we had in the video. So we don't need that anymore, and we don't need the script to stop for 3 seconds. So I remove the time.slip and this one as well. Okay. And now here, the first part is the most trickiest one. We need to figure out a way to store the current frame of the video. So as soon as the video starts, we want to store that numpy array in a variable and have that variable static, so we don't want to change the value of that variable while the while loop runs in the script. And the way to do that is we would first need to create a variable for the frame, for the first frame. So, and we need to assign it a none value. So none is a special Python data type that allows you to create a variable and assign nothing to it, but you have the variable there. So if you call this variable later, Python will not say variable is not defined. Okay, if you don't understand it, please hold on and you'll get it in just a while. And what you need to do now is to write a conditional and apply a continue statement in there. Let me write the conditional first and then I'll explain to you what this does. So we want to check if the first frame is none and if it is none, we will assign the first frame the gray frame. So what this does is that the script will run, the video will be triggered, and then the while loop will start to run and it will get the first frame of the video and it will store it in this frame variable. And this frame variable will be converted into a gray frame, and then we say if the first frame is none, which is true in the first iteration of the loop, this is true. So the first frame is actually none because we assigned none here. Assign the gray numpy to the first frame. So the first frame will get the grayscale image, which represents the very first frame of the video. So this happens in the very first iteration of the loop, okay? But then what will happen is Python will execute this other lines of code and then it will go to the second loop, and what Python will do is it will grab the second frame of the video. Okay, let's say the first frame was a background image, and then suddenly an object appears in the camera, in front of the camera. So Python will grab the numpy array that contains that object. So the second frame and this frame will be converted to gray, and then here we say if first frame is none, the first frame variable will get the first frame of the video. And once we have grabbed the first frame, we don't want these other lines of code to be executed. because here we will have, we'll apply the difference between frames, and we will blur the frames and so on. So we don't want these to be executed. Instead, we want Python to go to the beginning of the loop and continue with the second frame. To do that, we need to write continue here. So this means continue to the beginning of the loop, and don't go and run the rest of the code. Okay, so the first frame is none, and the first frame gets the value or the first image of the video, and then goes to the next iteration. And then the next iteration, what we'll do is it will grab the second frame of the video, and then it will calculate the gray version of that frame, and then it goes again to the conditional. And in this case, is the first frame none? No, it's not, because the first frame got the value of the gray image in the first iteration of the while loop. So these lines here will not be executed at the second iteration of the loop. Okay? Great. That means we can now apply delta frame. So we can calculate the difference between the first frame and the current frame of the image. So the first frame is the first frame variable, and the current frame is a gray variable. But before that, we would like to do something to the current frame of the image. We want to apply a Gaussian blur to the image. And a dot here. So the reason we want to apply Gaussian blur is that we want to blur the image, so we want to make it blurry, so to smooth it, because that removes noise and increases accuracy in the calculation of the difference. So this gets as parameter the image you want to blur, and then so we are passing the gray image here, and we are storing the blurry version of the image in the gray image again. And then we have another parameter which comes as a tuple, and here we need to pass the width and the height of the Gaussian kernel, so which is basically the parameters of the blurriness, but 21 would be accepted numbers. And you also need another last parameter, so that would be the standard deviation, and I'll pass 0. 0 here is also commonly used. If you want to learn about them, you can go through the documentation, but these values would be good. So we're making the gray image blurry here. And then down here now we need to compare the first frame of the image, so the background, with the current frame. Let's call this delta frame, and that would be equal to cv2.abs difference, so absolute difference between the first frame and the current frame, which is gray. Note that the first frame will also be the a gray version, a blurred gray version actually. So we are comparing here two blurred grayscale images. Okay, and what this will give us is another image. Okay, and actually I'd like to show that image here on the screen. cv2 image show delta frame. Let's see what we'll get out of this. And before running the script, I'll disappear from the view first, and then we'll appear. Okay, let's see. Okay, nothing happened because I forgot to enter the name of the window. Let's call this delta frame, and let's say gray frame for this. And let me run it again. And here I am. So this is a blurred grayscale version, this one here, and we have the difference. Okay, so you can see the lamp behind me in the delta frame. Great. Press the Q key and quit the video. Now if I want to print, just to check the delta frame, this will allow us to see the difference between intensities of the corresponding pixels. So Let me see. And if I quit this now, here we go. So what we have here, 5 means there is no difference. So in this area there's no motion probably, but then you have 174, which is quite wide. So that means Python will classify this as motion. Okay, that was just to show you the values of the delta frame. What we need now is to classify these values. So let's say we want to assign a threshold. So let's say if we have values that are more than 30, so if the difference between the first frame and the current frame is more than 30, we will classify that as wide. So we'll say there's probably motion in those pixels. So there's an object in those pixels. And if the difference is less than 30, we'll assign it black pixel. Okay, so we can do that. So we are here. We can do that using the threshold method of the CV2 library. Let's say thresh delta equals to cv2.threshold. And what this expects is the image that you want to threshold, and then you want to specify the threshold limit. So 30, we set 30. And what color do you want to assign to the values that are more than 30? Well, we want to assign a white color which corresponds to the 255 value. Okay, and you also need one more argument here, which is the threshold method. There are quite a few methods out there, but we are using this method here, so threshold binary. You can experiment with others if you like. Great. And now let's see how this thresh delta frame will look like. CV2 I'm show threshold frame. Okay, thresh delta. Great. Let's see. Apparently I wrote this wrong way. Delta frame, okay, not frame delta. And one more typo in line 19, which is here CV2. Okay, let's hope this time will work. And yet another error. And this time I've missed something here. Okay, this method here, so the threshold method, actually returns a tuple with 2 values. The first value is needed when you use other threshold methods. So the first item of the tuple basically suggests a value for the threshold if you're using other methods. But for threshold binary, you only need to access the second item of the tuple, which is the actual frame that is returned from the threshold method. So you want to access the second item of the tuple. Okay, I promise this is a loss error. Great, finally, and this is the threshold frame. So you can see my outline there, but you also see some white areas here because of the shadows. So I am being detected as an object, but my shadows as well as are being detected as objects too. Okay, so you get the idea. Now we can go right away and use this thresh delta frame, which I called it thresh delta. I should call it the thresh frame, you know, just for name consistency. And so we can go ahead now and create contours of the white objects in the thresh frame. But before that, I would like to do something else. I would like to delay those areas, so I want to remove the black holes from those big white areas in the image. So basically I want to smooth my threshold frame, and to do that you need to use the delete method of the CV2 library. And so let's say we want to change the threshold frame, CV2 delete again you want to pass the threshold frame there. Now if you have a kernel array and you want this process to be very sophisticated, you'd pass that array in here. We don't have any and we don't need one, so you need to pass none for this parameter. And there's yet another parameter here, iterations. Let's say 2. So this defines how many times do you want to go through the image to remove those holes. So the bigger this number is, the smoother the image will be. Okay, let me check it quickly. Oh yeah, I changed the name earlier, but I didn't change it here in the ImShow method. Thresh frame. Okay. So you can probably notice that the areas, the white areas, are smoother now. So if I go away, you'll only notice a few areas that are there because of my shadow. So it seems to be working so far. Let's quit it now. Great. So we've got these 3 frames. And what's next? Well, next is we need to find the contours of this dilated threshold frame. Regarding contour detection with OpenCV, you have 2 methods. So you have a find contours and a draw contours method. And with the find contours method, what you do is you find the contours in your image and you store them in a tuple. On the other hand, the draw contours method draws contours in an image. So in this case, what we want to do is we want to find the contours and then we want to check if the area of this contour, so let's say you have a contour like a circle, and so you want to find the area that this contour defines. So you want to store those contours in a tuple. So you want to write CNTS, comma, and another underscore. Okay, and that would be equal to CV2 find contours, and then you want to pass the frame that you want to find the contours for. And it's good to actually use a copy of the frame, so you don't want to modify the threshold frame. So use copy here. So this is the first parameter, the frame you want to find the contours from. And then you have the method retrieve external. So you want to draw the external contours of the objects that you'll be finding in the image. And you've got yet another argument, chain approx simple. So this is an approximation method that OpenCV will apply for retrieving the contours. Great. So what we have is we are iterating through the current frame. So we are blurring it and converting it to grayscale and find the delta frame and apply the threshold, so the black and white image. And then we find all the contours of the objects, of the distinct objects in this image. So if you've got 2 white continuous areas in your image, but they are distinct, you'll get 2 contours, so 1 contour for each of the areas. And these contours will be stored in this CNTS variable. So we're talking about the current frame. And next, what we want to do is we want to filter out these contours. So we want to check that we want to keep only the contours that are, let's say, that have an area that is bigger than 1000 pixels. For that, you need to iterate, let's say, for contour in CNTS, and if cv2.contour area of the contour, so the contour that we are iterating through, so if this is less than 1000, continue to the beginning of the for loop again. So what this means is, let's say Python found 3 contours, and it will go through the first one and it will say if the area of this contour, so we use the contour area of the CV2 library, if the area has less than 1000 pixels, go to the next contour. So go to the second contour and check again and again and again. Otherwise, if the area is bigger than or equal to 1000, the next lines here after the for loop will be executed. So what do we want to do if a contour is greater than 1000 pixels? Well, we want to draw the rectangle surrounding that contour to the current frame. So make sure you are inside the for loop. So we are still iterating, and so these are the parameters that define the rectangle, and that would be equal to cv2.bound rectangle of the current contour. So if the contour is equal or greater than 1000 pixels, so if it has an area of equal or greater than 1000 pixels, this will be executed. So we are creating a rectangle, and then we want to draw that rectangle to our frame, to our current frame. So cv2 rectangle. So we already consumed this method in our face detection lectures, and here we would want to pass the color frame. Okay, so that is the frame, and you want to specify x and y here. So these are the coordinates of the upper left corner of the rectangle, x, y, and you want to specify the coordinates of the right lower corner of the rectangle as well. So x plus w, just like that. And also the color of your rectangle, let's say green, and the width, let's say 3. So what we did in these two lines is that we created this tuple with these 4 coordinates, and these values, this will be assigned automatically. So x and y will get the value from the rectangle bounding this contour, this current contour of the for loop. And then these values will be used to draw a rectangle in the frame, in the current frame. And then we want to show that current frame. So let me add it here. Image show. Let's call this color frame and frame. Actually, this method here is bounding rect. Alright, let me try the script now. And cv2 has no attribute find contours. So here I've got a u there that shouldn't be there. Let's try it again. And yeah, but that's funny. I tend to mistype this word. Contour area. Line 24. Remove the u. And it should be contour here as well. Okay. Contour is not defined again. I've got another one here. So bear with me. Try again. And yeah, this time seems to be working. So no objects, no objects, objects. Great. Great, so that's what I wanted to teach you in this lecture, and we'll continue with the next lectures, because what we've done so far is that we can detect that object and we can draw a rectangle around that object. But this is not very practical. I mean, in real world, it's not enough to just draw a rectangle around your object and then that's it. So what we'll be doing in the next lectures is we'll be storing the times that the object enters the frame and when the object exits the frame. So we've got some more lines to add to this code. And I know this code here was quite a lot to consume, but I hope these are clear now. If you have any questions, please feel free to ask them. and I'll see you in the next lecture.